Welcome, everyone. Today we will look at the Andromeda Galaxy, also known as M31 in the Messier catalog. The Andromeda Galaxy invites a certain kind of awe because it reminds us that the universe is not merely vast, but intimately vast, filled with neighbors so distant that their light is older than our species, yet close enough to be seen with the naked eye from a dark field in the countryside. Andromeda is a grand spiral galaxy, a colossal, rotating archipelago of stars about 2.5 million light-years away. Through a telescope, it becomes a soft, elongated glow. Through imagination, it becomes a continent of suns, each with its own worlds, its own possibilities. It stretches roughly 200,000 light-years across, larger than our own Milky Way, and contains perhaps 1 trillion stars, 1 trillion suns, each a potential cradle for life, each a reminder that the cosmos is not empty, but overflowing with potential. Andromeda is a barred spiral galaxy, similar in morphology to the Milky Way. Its disk contains multiple spiral arms rich in star-forming regions, dense dust lanes that trace the galaxy's rotation, a central bulge dominated by older, redder stars, and a supermassive black hole at its core, with a mass of about 100 million solar masses. Surrounding the visible disk is a dark matter halo, extending hundreds of thousands of light-years, containing most of the galaxy's mass. This halo governs the motion of stars and satellite galaxies through its gravitational influence. The light reaching your eyes tonight began its journey long before the first humans shaped tools or painted caves. It has crossed intergalactic space, drifting through the dark matter halo that surrounds Andromeda like an invisible cocoon. When that ancient light finally arrives, it carries with it a message. Galaxies evolve, collide, merge, and renew themselves over billions of years. Andromeda's dust lanes, star clusters, and glowing nebulae are chapters in a story older than Earth itself. Andromeda is not alone. Two bright companions, M32 and M110, orbit it like small moons around a giant. And in the far future, Andromeda and the Milky Way will meet in a slow, stately collision. Not an explosion, but a long gravitational waltz lasting billions of years, eventually forming a new, larger galaxy. We are already bound to Andromeda by gravity. Our destinies are intertwined. Carl Sagan loved to remind us that by studying distant worlds, we learn about ourselves. Andromeda is a mirror held up to the Milky Way, a way to see our own home from the outside. Its spiral arms, its halo of ancient stars, its restless clouds of gas, these are clues to what our galaxy is and what it will become. To contemplate Andromeda is to feel both small and profoundly connected. Because we are one species on one world orbiting one star among 1 trillion in a neighboring galaxy. Connected because the atoms in our bodies were forged in stars, not unlike those that shine in Andromeda's arms. We are a way for the cosmos to know itself, and Andromeda is one of the grandest reminders of that truth.
The Andromeda Galaxy, our majestic neighbor in the cosmic dark. While it looks serene through a backyard telescope, we now know its history is written in the scars of a violent, gravitational bash-up. About 2 to 3 billion years ago, long before the first dinosaurs walked the Earth, Andromeda wasn't just sitting there. It was engaging in a massive, high-stakes merger with another galaxy, a lopsided duel featuring a mass ratio of 4 to 1. How do we know? Well, the stars themselves are whispering their secrets. Astronomers noticed something off about the way Andromeda's stars were moving, an anomalous relationship between their ages and their velocities. It turns out, 2 billion years ago, the star-forming engines of Andromeda were kicked into high gear, churning out new suns with a fury we just don't see in the galaxy today. Our computer models show that this wasn't just a fender bender, it was a total reconstruction. This collision forged the giant stream, a literal trail of cosmic debris, the metal-rich halo that wraps the galaxy like a shroud, the 10 kiloparsec ring, and that iconic central bar. For 100 million years, Andromeda would have been a luminous infrared galaxy, glowing with the heat of 1 billion newborn stars. If you had infrared eyes back then, it would have been the brightest show in the local universe. For a while, we wondered if the Triangulum Galaxy was part of this gravitational tango, a close flyby that stirred the pot. but the latest data from the Hubble Space Telescope, our premier eye in the sky, suggests that's unlikely. The measurements tell us Triangulum was probably just an innocent bystander. It just goes to show you, the universe isn't a static painting, it's a dynamic, evolving stage where galaxies collide and transform across the eons. For the longest time, we looked at the Andromeda galaxy and thought we had her all figured out. In visible light, she looks like your classic spiral, what we call an SASB galaxy. But here's the thing about the universe. What you see isn't always what you get. When we finally turned our infrared eyes toward her, using tools like the Spitzer Space Telescope, the dust cleared and the truth came out. Andromeda isn't just a simple spiral. She's a barred spiral, just like our own Milky Way. She's got this central bar of stars oriented about 55 degrees off-center. It's a family resemblance we didn't even know we had. Now, if you want to measure a galaxy, you can't exactly pull out a tape measure. We have to get creative. Astronomers use something called the D25 standard. We look for the point where the galaxy's blue light fades to a specific faintness, 25 magnitudes per square arc second. Back in the 90s, we pegged her at about 152,000 light-years across. But by 2005, the Keck telescope showed us that Andromeda is messier than she looks. There's a tenuous sprinkle of stars, a galactic halo, extending far beyond the bright disk. While the stars in the main disk are well-behaved, orbiting in a synchronized waltz at 200 kilometers per second, the stars in this halo are doing their own thing. They're moving in disorganized, chaotic orbits. When you factor in that diffuse halo, Andromeda's diameter stretches out to a staggering 220,000 light-years. Andromeda doesn't sit flat from our perspective. She's tilted at about 77 degrees. And as you look at her cross-section, she isn't a perfect flat pancake. She's got a bit of an S-shaped warp. Why? Because in space, nobody is an island. Gravity is always tugging. It's likely that her smaller satellite galaxies, maybe even the Triangulum galaxy, M33, are engaging in a gravitational tug-of-war, pulling her disk out of shape. The physics of how she spins tells us exactly what she's hiding at her core. By measuring the rotational velocity at different distances, we can calculate the mass required to keep those stars from flying off into the void. The data implies a concentrated mass in the nucleus of 6 times 10 to the power of 9 solar mass. That is 6 billion times the mass of our Sun, all packed into the center. The further out you go, the mass continues to climb linearly, reminding us that there is a lot more to these galaxies than just the starlight we can see. Finally, let's talk about those spiral arms. The legendary astronomer Walter Baade once described them as beads on a string. He was talking about H2 regions, pockets of hot glowing gas where new stars are being born. They are wound tightly, sure, but they're spaced out more than the arms in the Milky Way. Structured mess of star formation that's been going on for billions of years. Next time you look up at that faint smudge in the constellation Andromeda, remember, you aren't just looking at a cloud of light. You're looking at a massive, warped, barred spiral powerhouse that's currently on a high-speed collision course with us. But don't worry, that's a story for 4 billion years from now.
Right now, the Andromeda Galaxy, a majestic spiral of perhaps 1 trillion stars, is barreling toward us at a staggering 110 kilometers per second. Now, if you're sitting on the Sun, it looks even faster, about 300 kilometers per second, because our own Sun is busy orbiting the center of the Milky Way at its own clip of 225 kilometers per second. In a universe where most galaxies are fleeing from us, thanks to the relentless expansion of space, Andromeda is a rare rebel. It's one of only about 100 observable galaxies showing a blue shift. That means its light is being squashed toward the blue end of the spectrum because it's headed straight for our front door. For a long time, we thought a head-on collision was a mathematical certainty in about 4 billion years. But wait, the plot thickens. To know for sure, you need to measure the tangential velocity. That's the sideways motion. Newer data from the Gaia spacecraft, combined with the gravitational tug-of-war from other galaxies in our local group, suggests Andromeda might have more side than we previously thought. This extra bit of sideways hustle means a direct, catastrophic hit is actually less certain than we once predicted. A new galactic neighborhood. If they do meet, don't think of it as a crash in the way two cars collide. Galaxies are mostly empty space. It's more of a cosmic ballet. The two would dance around each other, eventually merging into one giant, glowing elliptical galaxy, or perhaps a massive new disk. What about us? What happens to Earth? To the solar system? The good news, the distances between stars are so vast that it's highly unlikely any individual star will slam into our sun. The wild card. Gravity is a powerful choreographer. There's a small, non-zero chance that our entire solar system could be flung out into the lonely darkness of intergalactic space, or perhaps find ourselves with a brand new home in the Andromeda suburbs. We don't know the final fate of our descendants yet, but one thing is for sure: the night sky of the distant future will be absolutely spectacular. In conclusion, Messier 31 is far more than just our nearest neighbor. It served as the key that unlocked the true scale of the universe. It provides a vital blueprint for understanding our own galaxy's structure, and it offers a preview of our inevitable future. To study Andromeda is to study the past, present, and future of the Milky Way itself.